So thanks for waiting. The schedule is a little bit messed up, but now I'll talk about simplicity, Symphony, and the web. Let's get started. My setup is a little bit messed up too. So first I want to introduce you to what we're trying to solve. With simplicity, we're trying to solve Bitcoin smart contracts. That's the general goal. So simplicity is a kind of programming language that is supposed to be better and solve problems that Bitcoin script has and problems that the EVM has. And the way we do this is simplicity consists of a very small set of operations. We call them combinators. And with those combinators, we do everything. we do everything we want to do. Let's see. It's so small that it fits on a T-shirt, which is here. That's the T-shirt. You can get them outside. I mean, this is only like XL, so not my size, but I implemented simplicity too many times in different ways, and I can attest that it is so simple. It only has 9 commands, give or take, that it is very easy to implement. This means we have like some sort of risk-like runtime. We only have like a very small runtime, very few lines of code for what it does, which means the runtime is very predictable. It has few lines of code, which means we can look at those lines and see, do those lines implement what I think they should implement? We can even go one step further and say, I can write a specification which says each command, each combinator is supposed to do this if it sees these inputs. So we specify, given these inputs, we expect these outputs. We cover every single case, which is possible because we don't have that many cases. We only have 9 combinators, so we only have a few cases to cover. And then we can write a proof that says, this code is correct. This code, the runtime, the C runtime, satisfies the specification, which is a kind of security on Bitcoin which does not exist. Simplicity is powerful enough for smart contracts, so it's more powerful than Bitcoin script is today. But at the same time, it does not have infinite loops, and it's weak enough to analyze. So if the scripting system is too complex, if it enables infinite loops and so on, it's impossible, it's intractable it's impossible to track all the different cases. And in general, it's impossible to analyze, to, for instance, bound how much memory can my program use, how much time it will run, and so on. With simplicity, we can do these kinds of things. There's one problem with simplicity, though, which is it looks a bit like an alien language. So as an example, the majority function, so we have 3 bits, and we want to see if the majority is true or false. So for instance, if we have 001, then the majority of bits are false, so we say the majority is false. And if we have 011, then the majority is 1, so we output 1. And this is how we write the program. Cont, true, ident, false. And cont is actually a macro for 3 combinators. It's for case, drop, and true is left injection unit, and false is right injection unit, and false is left injection unit. And it's kind of, yeah, that's, what is that? That's kind of, it's kind of cool, but no one wants to write this kind of stuff. This is confusing. This is where most people, like, you read maybe the tech report, the white paper, stop, and they think this is too complicated for them, so they will no longer be interested in simplicity. Simplicity is like functional assembly. So this means we have no variable names, we have no mutability, We have no data structure, so we cannot define a class or some sort of bigger blob of data and do something on this bigger blob. We have to always work on sums and units and products. You can think of it as working on like single bits instead of like bytes or like hashes and whatnot. There are no real functions. So a simplicity program is a function, but you cannot like define f of x and then call f of x with different arguments. It's impossible. So it's like not very nice to define functions and use them in simplicity. And there are also no loops. I mean, first of all, there are no infinite loops because this would make the language intractable. It would make analysis impossible. We don't want that. We can have bounded loops, but writing these loops, there are different trade-offs, there are different ways to do this, different caveats. And this is definitely non-trivial to do. So normal programmers would not be able to write loops, I claim. Yeah, just repeat this like 1,000 times or like that kind of stuff, right? Like you can repeat the same thing 1,000 times, but maybe you want to write it in a more compact way or in a way that enables compression. So there is this way in simplicity where if you repeat the same thing multiple times, you can collapse it into like one thing. If you repeat one thing 1,000 times f, you only have f once in the program, but you have to be clever how you write the program, so it's actually compressible. So this is one of the caveats I talked about, and these are things that if you just write simplicity off the cuff, you don't know about this, and suddenly you pay like 1,000x more fees, and you're like, okay, what's going on here? So let's not write assembly, let's do something else. And this is where we go to a compiled language, which is called Simphony with an F. So Simphony is a high-level language for humans, a high-level language which Bitcoin developers can write. It looks and feels like Rust, and it's compiled to simplicity. So like Rust, you take Rust, you write Rust, and you compile it to assembly. Rust is written by Rust developers, and assembly is executed by computers. Simphony is written by Bitcoin developers, and simplicity is executed by Bitcoin full nodes. That's the idea. What does it look like? It looks like this, for instance. Do I have a laser pointer or something like that? I don't have to have one. I can point with my finger. Oh, that's like technology. Yeah, I mean, you can see you have let statements. You can have like scopes and stuff. You define some unsigned integers, which awesome. You can have like unsigned integers, which are not like natively supported by simplicity. You do some equality checks. You can compute some arithmetic. So you take a maximum of 2 integers and check if the maximum is equal to something else. This compiles in the Rust compiler. This is valid Rust. You can have functions, so you can define like a 32-bit integer addition, and in a way that it takes 2 32-bit integers and it returns a 32-bit integer, and it panics if there's an overflow, because maybe that's an API that is more useful for you. And then you can call this function and check that the output is the expected output. You can have match statements. So you can give it some value and then match over the different cases and say, okay, if I see this kind of value, I execute this code. If I see this kind of value, I execute this code. Or here, if I see a true bit, I output a 1. If I see a false bit, I output a 0. And then you can do whatever you want to do with it. So this is also valid Rust. This compiles in the Rust compiler. And in general, what I found out is that Rust is really compatible with simplicity. It's like Rust is a mainstream language, and it has these functional features like the pattern matching and the match statements that are exactly like simplicity, but they just look different. And we can use this to make simplicity much more approachable. And you also have loops. So here, again, you have this 32-bit integer addition, and you have some sort of list of integers, and then you can sum them and check that the sum equals to some amount. And the list is also, these lists are arbitrary length up to a certain maximum. So you can work on arbitrarily length lists and stuff like that. So this is Simphony. I encourage you to read more in the documentation that we have. It has a lot of cool features. But I think this is like maybe a show of hands. Like, is this more readable than what I showed before? Like, is this more readable? All right. I'm glad to hear that. I think it's also more readable. So Simphony, there's a lot we can do about this. It mainly depends on what you want and how far you let us go, but we want to add data structures. So right now we have like a few unset integers, booleans, and so on options, but there are also things like elliptic curve points and elements, assets, and stuff like that we want to add. And then we want to define a standard lib. For instance, adding a plus or adding integer arithmetic and adding equality and stuff. Methods that work on these data structures and on these types. We also want to optimize the simplicity that is generated. Right now, the compiler is not very efficient. We want to add debugging features. So basically, if you develop Simphony, you can forget about simplicity. Like, if you debug, you shouldn't need to look at the assembly code. Like in Rust, we try to emulate the Rust experience. So if you debug Rust, you almost never look at the assembly. You always have some sort of stack trace, and you can look at a Rust expression that failed, and you can stay in the Rust framework. And we try to let people stay in the simplicity framework. Simphony, sorry. And yeah, Simphony, we will integrate it into more tools. So we have like a wallet for simplicity, and we also have something that I will talk about next. So we want Simphony to work with the existing tools. Simphony, if you can compile it to simplicity, but maybe you can also import it directly. You can import directly Simphony code, share it with your friends, edit. It's much more readable than simplicity. And then we did a thing. We thought, why not put it on the web? We have a Simphony IDE. So I spent some time making sure that simplicity runs on WASM, compiles on WASM. And then I built a website where you can run programs, and you can like write programs, get some syntax, get like some parsing errors and stuff, get some feedback while writing the program, and then you can run it and see what happens. So you can select an example program. Like we have some, like the empty program is like a valid string, valid program, and we have some examples of the different syntactic features that simplicity offers. And then we have some, I guess this is like the old version, some examples how you can use Simphony for actual Bitcoin use cases. So maybe a Schnorr verification or like opcat and stuff. And this is a workshop kind of, so a short presentation, then we can like look into that like live and explore this live if you want. You run the program, so you select the program, you run the program. There's an analysis, so it tells you how big is your program, how much would it weigh, and so on. Then you can maybe look at the current fees and calculate how much that would cost. gives you like a maximum memory usage, maximum runtime usage, based on how long a block is supposed to be valid, how much time you're supposed to spend on each weight unit. If we assume like that one block is validated in 2 seconds. And if there's any error, you get a stack trace. So you can play around with examples, and the examples all run. And if you change something, like if you change the signature slightly, then of course the signature is invalid. And then you can check what the runtime tells you and where it failed. The web IDE, I mean, this is all like experimental stuff. So the web IDE will get some syntax highlighting and some more helpful errors. What I'm excited about is like a Merkle tree explorer. So the simplicity program is also like this Merkleized abstract syntax tree, this Merkle tree. And so, but it can be pretty big. So we will add this interactive, like scrollable Merkle tree explorer where you can like go through the program and take a look at what you would put on the blockchain. There will be a debugger, so you can, basically it will be like, we're trying to emulate the Rust experience. So if you can go through the program line by line and take a look at the current state, what are the variables, what are they defined, and is there any deviation from what I expect? Are the variables, is the state exactly as what I expect? And then you can look for errors. And you will also be able to set a transaction. So things like the signature hash depend on the transaction. And right now there's a hard-coded transaction, but in the future you can change it. And so with the web IDE, you can create a simplicity program /Simphony and make sure that it runs in your contract setup before you put it on some sort of blockchain that runs simplicity. So what are your next steps? You should try the web IDE. Try the example programs. See if they run for you. Try, play around with them. Make them fail. See what makes them fail. We have some documentation about Simphony if you want to go a little bit deeper. And then provide feedback, because we need feedback. And this is like, I would say, community effort, because this is a lot of work. We are a very small team. We hope you're excited about Simphony. And I would say thank you and try it out. Yes. Does it use the Rust compiler to check the validity of the program? No, like the compiler is written in Rust, but it's a custom Rust program, right? So we can enforce the specific rules for Simphony. Like, maybe you're confused. Like I said that I implemented simplicity in the Rust compiler at some point and in different ways, but this has nothing to do with this project. I see. Yeah, I see. Actually, there's this one place where we have invalid Rust syntax. I think we will fix it in the future. But there's this one semicolon that is not allowed in Rust, and so it's not it's not valid Rust.
It's Rust-inspired syntax. You're not able to reuse like the Rust grammar or lectures or parsers or anything.
Yeah.
Because of this one semicolon. If you part of your spec, you might be able to reuse those, but the rest of the Rust compiler, additional constraints on the syntax, which would not be compatible.
Yeah, exactly. That's a good summary. Like, the goal is to define like.
Paraphrase that.
Okay, awesome. So like Simphony looks like Rust, but it is not exactly Rust. Right now, you cannot compile it with the Rust compiler. You have to compile Symphony with the Symphony compiler. And the rules for Rust are not the same rules that are for Symphony. There's a question?
Okay, so I'm new to this. Does the restoration project that was talked about previous, does it help get this in, or do you need a different software? Can you explain what it looks like to actually use this?
Okay. Yeah, okay. I think the restoration is definitely aligned. So it also tries to make script more usable. But to get this in, like in the, you would need a soft fork. Like you can try to run on bit VMs, that kind of stuff. But that's a trick, right? That's not running the literal contracts in one transaction.
There is no like soft fork yet proposed?
Yeah. Like we want to get it on Liquid first and try it out there, because this is a pretty big update. Like Rusty talked about the big script restoration, but we have like the bigger restoration. So there needs to be discussion, and there needs to be like thorough testing before we even propose it on Bitcoin.
The idea is to move this to maintain eventually, but the first test on Liquid.
Yeah, I think that's fair to say. Yeah, okay. You have a question? What do jets look like? Okay. Yeah, I mean, jets are basically inbuilt functions. So right now, jets always start with the word jet underscore. I think in the future we might like change the syntax a little bit, but here, right? Like this is jet underscore verify, jet underscore equal 32. So those already exist. You can use them immediately. And things like checked adds are functions you define. And those are not jets. That's the difference. Here's a question.
Yeah, well, I heard somebody asking about jets. Would it be fair to say that jets are sort of like the standard libraries in C? They're things that have already been implemented. So they are implementations of functions which could be done in simplicity, but which are provably equivalent to the simplicity jet.
Yeah, that's right. Jets are, you have a list of useful functions. You want to compute useful algorithms, and you have some sort of simplicity program that will compute this, but it's kind of large. So you define C code, which does the same thing, and then use that instead. And you have some sort of proof that says the C code does the same thing as the original simplicity code. So the C code needs to be correct. So it needs, for instance, it needs to compute a correct addition, or it needs to compute a correct EC mult.
Use like a verified compiler, C compiler. Already caught, right?
Yeah, we have, well, the jets are written in verifiable C, and then we use Coq to verify the verifiable C. So we say, if we have these conditions, like if the inputs look okay, the outputs will also look okay. If we supply the addition function with valid inputs, it gives us the valid outputs, which are the added outputs. Awesome. Question? Yeah, like in the current design, you would need a soft fork. So the idea is we have this list of useful jets that we want, and we discuss like which jets do we want in Bitcoin Core in the soft fork. But once we have that, we commit to this list. And if we change it, we can have a new version of simplicity, which has like a different list, ideally a longer list, not a shorter one. But adding a jet is a non-trivial thing. There are ideas maybe how we could like have user-defined jets, but this is like highly experimental, and I'm not sure if we will ever have that. That's a question. Mm-hmm. Yeah. It's closer, yeah. So how does the cost model work in simplicity? So this is closer to what Rusty explained with the var ops limit. So it's not, I mean, in Bitcoin, in the end, you pay for the size, but this is a very crude kind of measure. In simplicity, we have these combinators and we have these jets, and especially some of these jets are really much more expensive. Like an easy elliptic curve addition is much more expensive than just an integer addition or something like that. So we are basically running benchmark like Rusty, and we are assigning costs to each jet and to each combinator. We calculate the total cost of the program, and then we make sure to be backwards compatible that the size of the program is like enough to represent this weight. So we need to
or weight or both.
So there's only, in the end, we only have the weight, but we must make sure that the weight is like pays for the CPU cost of the program. So you can imagine a program that is very small but very computationally expensive, and in that case we have to pad like extra bytes. It's like, I think it's still like an open question how exactly we could do this. We could maybe use the annex and say, like ideally we don't just add like 0 bytes. We say we just have a number and it says like this many bytes are like virtual bytes are in here, like phantom bytes, and then you have to pay for all of these bytes. But the idea is that we want to keep these things simple and not introduce like a second measure for the cost. Okay, there was one question here.
The relationship between the chats and like input output, because like you can have library for math and cryptography, but completely different question is like, can you read the transaction, can you read the block header, can you read the whole blockchain, or like what kind of inputs, how do you get inputs?
Okay, so the question is what kind of introspection can we do in simplicity, and is there like blockchain-wide introspection? Can we like look at the Genesis block or block 1, block 10, that kind of stuff, right? So one of the design goals of simplicity is to keep the introspection to the transaction. So there is no like arbitrary blockchain introspection. We can look at the spending transaction, and that's basically it. So, and the list of jets defines what introspection we allow. So in a hypothetical world where we don't want covenants, we could say, okay, we don't add any introspection jets, and then simplicity cannot do covenants. Or we could say we go like all in, the entire, like everything in the spending transaction can be introspected, which is the more likely scenario, and then we have covenants. But we will never have arbitrary introspection. Like there's definitely a limit, and the idea is that if you run simplicity, you don't need caches. You don't need to cache like new data, new stuff, because suddenly you have all of this introspection, right? But if you run like a pruned node, you should still be able to run the simplicity programs.
In the IDE or not yet?
Okay, that's a good question. So do we have introspection in the IDE? Let's see. We actually have, yeah. Open your phone or laptop. Let's go. Because this is supposed to be, like, go to this website. I will try. Yeah, like, but look at this resolution, man. It's like, what's going on here? It's like, this is not good resolution. So we can go to OpsCDV and stuff. This is OpsCDV in, like, approximated in Simphony. And here, right, like you have jet version, jet log time, blah, 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 all of this stuff. So this is all introspection. You have a hard-coded CDV hash, so the expected hash, and then you verify and you click and it works.
So I have a sort of a complicated question. and this is more about Symphony, not about simplicity, which is, in Symphony, is there something akin to, in C, I can declare code inline, and so I can insert lower language, lower level assembly into it. Is there a way to do that in Symphony where I can do inline simplicity that's not implemented in Symphony?
Not right now, and I haven't seen that a lot in Rust. So, if there's a case to be made, yeah, like if there's a case for like as a macros like inline simplicity inside Symphony because you want to optimize something or there's some feature that is not supported by Symphony. If there's a case for that, we will add it. Right now, it's still too early for that. We can.
I mean, it's just the idea of if somebody is working in Symphony and knows how to do something in simplicity and finds that they can't get there in Symphony, what's their escape hatch to go down to the lower level thing that you're compiling into?
Yeah. No, I think those will be like questions that we will have to think about once people actually use this, right? It's like.
Yeah, sure. That was, in fact, what was done before they added inline to C, but it's pretty freaking ugly.
Yeah, so the compiler doesn't give you a lot of guarantees right now. Like, in theory, every time you compile, there could be a different program. This is not the case, but, that's kind of the guarantees you get.
Right.
So, not a lot of guarantees. And to lock a lot of value in a Symphony program would require you to take a look at the assembly and make sure that it implements what you want to implement. For now, we have to keep the scope kind of small because there's I'm the only guy working on this. So but it's a really cool idea. And, if this matures and if people use this more and if there's demand, then I'm sure we will add it. Okay, that's a question.
How is it so fast?
How is it? Yeah, I mean, the thing is, why is it so slow? I would say because like here, for instance, you have the worst example, the firecracker, which crashes your browser, or it doesn't, but it's supposed to run in 4 microseconds, or milliseconds, but it takes 1 second in the browser. Simplicity is just very cool. It's very fast. That's the answer. We're still working on optimizing the WASM and stuff. It takes too long to download. You have this 2 megabyte blob and stuff, and unfortunately WASM needs to load everything at once and then it's there. Cannot be loaded in stages, but yeah, I invite you to try it out and give us feedback. There are ways to crash it. You can find them. Open GitHub issues or just write me on Telegram, and let's make Symphony the best it can be, I would say. Cool, and thanks again.